Its weapon does not explode, does not fire projectiles, and costs less than $20. Yet, on Ukraine's front lines, it is defeating Russian unmanned aerial vehicles, UAVs, and reversing the dynamics of high-tech warfare. With UAVs dominating the battlefield, from kamikaze first-person view FPV drones to long-range loitering munitions, countering them has become as critical as employing them. Ukraine's defensive systems currently range from multi-billion-dollar Patriot batteries to improvised shotguns mounted on quadcopter drones. This device, however, is in a class of its own. It is the Aero Trawl. Yes, it is another modified UAV, but the crucial distinction is that it does not merely destroy enemy drones, it captures them intact in mid-air and delivers them undamaged to Ukrainian forces. Before proceeding, comment number 1 if you support Ukraine, number 2 if you support Russia, and number 3 if you love peace.
What is most valuable to Ukraine's budget-constrained military? The Aero Trawl costs less than $20 and is extremely easy to mass-produce. Let us examine how the Aero Trawl actually operates and why it could prove a game-changer for Ukrainian frontline troops.
Ukraine's fight against Russian UAVs unfolds on two distinct fronts. On one, the country must repel nightly long-range strikes by Russian missiles and Garan kamikaze drones targeting cities and critical infrastructure deep behind the lines. There, Ukraine employs a layered mix of missile systems such as Patriot and Iris-T, air-to-air missiles launched from fighters and helicopters, electronic warfare, EW suites, and mobile gun systems like the German Gepard. All are supported by radar networks, thermal detection systems, and even acoustic sensors to identify and track incoming threats for engagement.
On the other front, Ukrainian forces must contend with the pervasive threat of drones over the forward edge of the battle area. Two primary categories dominate this equation: reconnaissance drones and FPV kamikaze drones. For both sides, reconnaissance drones are essential for operations on and immediately behind the battlefield. Since Russia launched its campaign in Ukraine in February 2022, Russian reconnaissance UAVs have continuously swept the battlefield and surrounding areas, designating targets for artillery, glide bombs, and strike drones. Ukrainian reconnaissance drones perform analogous roles.
The most widely used Russian reconnaissance drone is the Orlan-10, a low-cost, mass-produced fixed-wing platform employed extensively for intelligence, surveillance, and reconnaissance (ISR) missions since 2010. It can be catapult-launched and is directly controlled by Russian artillery units, making it ideal for rapid targeting of Ukrainian positions. The Orlan-10 carries various sensors, including electro-optical and infrared cameras, while some variants incorporate the Lear-3 electronic warfare system, capable of jamming radio and cellular signals within a 3.7-mile radius.
Russia also employs the Forpost and Forpost-R reconnaissance drones in Ukraine. These medium-range, long-endurance platforms, derived from Israel's Searcher Mk2, are used primarily for surveillance, but can carry small laser-guided munitions in combat variants. Ukraine additionally faces short-range surveillance drones, such as the Zastava, based on Israel's IAI Bird-Eye, the fixed-wing Tachyon, optimized for covert operations, and the commercial-grade fixed-wing Zala 421-16E5 HD, used for infrastructure inspection and artillery target designation.
These drones maintain persistent surveillance over adjacent rear areas, hunting tanks, artillery, communications equipment, electronic warfare systems, and, in recent months, UAV control teams and launch sites. Consequently, neutralizing these spotter drones as early as possible is critical for Ukraine. Denying the enemy its eyes yields significant tactical advantage, allowing Ukrainian forces freedom to reinforce positions, maneuver, and resupply frontline units without immediate detection and attack.
Initially, Ukrainian infantry on the front lines relied primarily on pump-action shotguns firing birdshot and short-range handheld electronic warfare devices to engage these drones. Such systems jam the radio control signals of Russian drones, causing them to miss targets, crash, or in some cases return harmlessly to their launch point. Today, it is rare to see Ukrainian frontline infantry without an EW device and a shotgun. They have become standard issue for tank crews, artillery units, and communications teams.
Their effectiveness, however, remains limited. First, the immense length of the contact line makes comprehensive EW coverage extraordinarily difficult and expensive. According to Ukrainian Commander-in-Chief General Alexander Syrskyi, as of September 2025, the line of contact stretched approximately 800 miles, an increase of about 125 miles from the previous year, forcing Ukraine to manage 160 to 190 daily engagements. Ukrainian EW systems, such as Bukovel AD, can jam drone signals out to 12.5 miles, but frontline deployment typically involves man-portable units emplaced in trenches with shorter ranges of 1 to 3 miles. That means continuous coverage requires systems deployed every few miles, particularly in high-threat sectors. Analysts estimate that with an average 1.2-mile coverage radius per EW system, Ukraine would need roughly 600 networked units for effective front-wide protection. Handheld jammers and more advanced systems like Bukovel cost between $500 and $10,000, mostly in the $1,000 to $3,000 range. Assuming an average price of $2,000, Ukraine would require approximately $1.2 million for the equipment alone. Adding spares, maintenance, operator training, and command system integration, total costs could reach $1.5 to $2 billion.
Shotguns, by contrast, are far cheaper and more plentiful. In addition to imported models from the U.S. and Turkey, in May 2025, Ukraine's Ministry of Defense approved 3 domestically produced 12-gauge pump-action shotguns for service. These Ukrainian-made 12-gauge weapons fire 3-inch shells, either solid slugs or birdshot. When loaded with birdshot, they have proven effective against close-range UAVs, especially during terminal attacks. While exact prices are unclear, new pump-action shotguns typically range from $200 to $350. They are thus relatively inexpensive compared with other weapons, yet they remain a last-resort lethal option against drones and are not the foundation on which a robust anti-drone defense should be built. Ukraine would need tens of thousands of shotguns to fully equip frontline forces at a cost of tens or even hundreds of millions of dollars. Even then, while birdshot patterns increase hit probability against Russian drones, success still depends on human skill and composure, qualities not always available in chaotic battlefield conditions.
Around 2024, Ukraine developed a new approach, using its own FPV drones to attack Russian reconnaissance drones. Cheap, plentiful, and lethal quadcopters could be employed to destroy both Russian FPV kamikaze drones and larger, more expensive reconnaissance platforms like the Orlan 10. With annual FPV production estimated in the millions, Ukraine had ample supply of these few $100 drones for the task. The tactic proved effective. Initially, Ukrainian drone pilots downed Russian UAVs through kinetic impact, simply ramming modified FPVs into them. Over time, explosives were added to these miniature interceptors, allowing them not only to knock Russian reconnaissance drones from the sky, but to destroy them outright. One limitation persisted. While the tactic successfully eliminated Russian drones, it also destroyed the Ukrainian interceptor in the process. It was essentially a one-for-one drone exchange with no salvage value. Ukraine's solution? Mount shotguns directly on its drones.
These armed drones could launch, fire the attacked shotgun at the target, then return intact for reuse. Early efforts, however, revealed new problems. Shotgun-equipped drones could fire only 1 or 2 rounds before reloading, and if recoil was not properly balanced, the shot could flip the drone in flight, causing it to crash.
This is where the story's central figure enters. Andriy Pavlovsky, a Ukrainian engineer, developed one of the first shotgun drones. He began building weapons early in the war, producing logistics robots and mine-clearing robots for friends on the front lines. When the sky became the new battlefield, he shifted to designing tools to defeat Russian FPV and reconnaissance drones. His first success was developing and patenting a recoilless shotgun round that produced virtually no significant backthrust on an airborne drone platform. That ammunition could solve the recoil problem for Ukraine's shotgun drones. Concurrently, however, Pavlovsky worked on an even simpler device, the Aero Trawl.
As noted earlier, the Aero Trawl does not merely shoot down Russian drones. It enables their live capture and delivery to Ukrainian intelligence. Initially, Pavlovsky focused on recoilless shotgun ammunition, believing it held greater potential. Field experience, however, showed the Aero Trawl to be his first invention widely adopted. The device is patented and available on the Brave One platform, a decentralized Ukrainian military procurement marketplace, for approximately $18.50 each. According to Pavlovsky, several hundred units have been delivered to frontline units for tactical development, pilot training, and feedback to refine the system. Reports indicate it has been used against Russian reconnaissance drones, FPV drones, and ambush UAVs, typically fiber-optic-controlled FPV drones that Russia stations in standby along roads. When Ukrainian vehicles or troops are detected, these drones activate and attack, often achieving complete surprise.
How does this innovative system work, and what makes it attractive? In brief, rather than firing projectiles or missiles, the Aero Trawl is a device attached to a carrier drone that captures Russian drones in a trailing net. Visually, it resembles a maritime trawl net of the type used by fishing or minesweeping vessels. The concept of using nets to trap drones is not new. Multiple net-based systems exist, and some have seen use in Ukraine. The best known is probably Fortum Technologies' Drone Hunter F700. This autonomous VTOL drone employs a proprietary net gun system to rapidly deploy expanding nets against adversary drones. It offers 2 variants, a smaller net for offensive mode, targeting Group 1 and 2 FPV-type drones, and a larger net for defensive mode, intercepting faster, larger fixed-wing drones such as Garan. Captured drones are tethered and lowered safely for technical analysis.
Aero Technologies' Defend Air is another multi-configuration net-based anti-drone system. It can be deployed via interceptor drone, fixed turret, or handheld net launcher, capturing drones in mid-air with nets ranging from 30 to 330 feet and engagement distances from 6 feet to over 295 feet. It integrates with radar and RF systems and is designed to minimize collateral damage in sensitive urban areas. Other net systems are tailored for specific scenarios. OpenWorks Engineering's Skywall Patrol, for example, is a fully man-portable system that fires a net attached to a parachute to ensure controlled descent of captured drones, minimizing damage for intelligence recovery. Similarly, Ondas Iron Drone is an AI-enabled autonomous drone that uses ballistic nets and parachutes to safely capture and lower adversary drones. Russia has also experimented with net-based anti-drone systems, and as we will see, this influenced the Aero Trawl's development. Russia's NetComet system employs small interceptor drones that deploy nets to entangle Ukrainian drone rotors in flight. Both Russia and Ukraine extensively use fishing nets strung across key logistics routes to prevent enemy drones from diving onto vehicles.
With these systems already on the market, the Aero Trawl faces considerable competition. Yet it offers several key features that provide clear advantages over more elaborate and expensive alternatives. First, the device is purely mechanical, with no onboard electronics, and mounts on a quadcopter with a 10 to 15-inch frame. Unlike hanging fishing nets on roads, all other net systems incorporate electronic components, increasing cost and assembly complexity. Additionally, every other system, including Russia's, uses relatively standard mesh nets. The Aero Trawl employs vertical slings, thin, high-strength lines designed to wrap around an adversary drone's propellers rather than envelop the entire airframe. The complete system weighs just over 10.5 ounces, significantly lighter than shotgun-armed interceptor drones, which are typically 5 times heavier.
The device's lightweight minimizes impact on the carrier drone's flight performance and endurance compared with heavier electronic and net-equipped systems. The Aero Trawl's sling structure also avoids aerodynamic penalties, and the fin lines are nearly invisible to adversary operators, especially at range or with Kevlar variants Pavlovsky has tested. Employment is extremely simple. The Aero Trawl can be attached to a drone in about 1 minute using ties or clips and is deployed immediately upon takeoff. In an exclusive interview with Ukrainskaya Pravda, Pavlovsky detailed operation. First, the enemy reconnaissance drone is detected by radar or visually. Then a launch order is given and the carrier moves towards the target. Obviously, the Aero Trawl is most effective when the carrier UAV is equipped with a thermal camera, as this allows the operator to clearly see the adversary drone and approach it. Multiple approach attempts can be made to capture the target. At the moment of capture, the Russian pilot has no idea what is happening. The Trawl is invisible from a distance, and even if the camera is pointed towards the Ukrainian drone, it is already too late to do anything.
Another distinguishing aspect is that the Aero Trawl is specifically designed as a defensive tool, primarily over Ukrainian positions at the front line. As Pavlovsky stated, this system is for assault units and infantry regularly in trenches, where enemy reconnaissance drones are a major problem, adding that I also focused on special forces in frontline missions. In contrast, most other net systems are intended for dual offensive-defensive roles and broader ranges, such as protecting infrastructure from long-range Garand drones. In this frontline defensive role, the Aero Trawl offers 2 disposal options. The trawl can be released after entanglement, causing immediate crash, or the captured UAV can be towed rearward for study once its battery is depleted.
Perhaps the greatest benefit the Aero Trawl provides Ukraine's military is cost and scalability. Compared with alternatives, the $18.50 per unit price is extraordinarily low. The handheld Skywall 100 launcher costs roughly $20,000, excluding net projectiles. Defend Air and Drone Hunter systems are estimated to cost tens, if not hundreds of thousands of dollars each. Even Ukraine's own Varta Drone Hunter, a shotgun-armed interceptor priced at a modest $325, is 17 times more expensive than the Aero Trawl. Clearly, at under $20, the Aero Trawl delivers an outstanding cost-per-target ratio. According to Pavlovsky, currently a Russian ambush drone costs about $1,000 to $1,500 and a DJI Matrix 4T around $5,000. It must be painful to watch expensive drones destroyed by such a cheap, simple device, and that is precisely what Russian forces are experiencing. Pavlovsky reports 1 Ukrainian unit mastered his system and downed 14 Russian UAVs in 15 sorties using the Aero Trawl. That is an outstanding kill rate by any standard.
Meanwhile, development and refinement continue based on battlefield experience.
Pavlovsky has adapted the Aero Trawl to carry explosive charges for mine-laying and attacks against higher-value targets, such as antennas, fixed communications towers, and artillery barrels. Range testing shows drones can deliver charges effectively and depart before detonation. He is also experimenting with different sling materials, with Kevlar proving highly promising. They are completely invisible in the sky, both from the ground and from a drone camera, he said, adding that only at about 10 feet can the captured drone's operator detect them. Ultimately, we chose larger slings. They make the system even cheaper.
The concept was partly inspired by Russia's Net Comet system, or more precisely, by its shortcomings. The rectangular design of Russian drones creates a sail effect, reducing high-speed maneuverability and control. The net itself can be blown back or deflected by wind. That means very high pilot skill and favorable weather are required for effectiveness. Even then, the vertical net prevents towing captured UAVs back or carrying explosives for separate attacks. Ukraine's Dronarium Drone Academy, which demonstrated a similar design in Japan in 2015 and encountered the same issues, also influenced Pavlovsky. I was able to solve problems from a decade-old design by taking a completely new approach, he recalled. We conducted some tests with experts from the Dronarium Training Academy. They were very interested, and I proposed incorporating the Aero Trawl drone capture system into the Academy's training program.
The substantial advantages it offers Ukrainian forces and such promising early results, the next evolutionary step for the Aero Trawl is mass production. On that front, Pavlovsky will certainly need additional help. A single person without technical training can produce up to 10 Aero Trawl units per day, but to date he has done everything himself. Plans for genuine production scaling are underway, and who knows, perhaps the next time we report on the Aero Trawl, it will be one of Ukraine's most ubiquitous and recognized weapons, and possibly those of many of its allies. Comment number 1 if you support Ukraine, number 2 if you support Russia, and number 3 if you love peace.